Welcome back to CET466 Logic Design. And there's the reminder, this is being recorded. Feel free to watch on YouTube if you don't like being recorded. The chat isn't on Discord isn't being recorded, but the things I'm sharing and the things you say in the voice channel will be recorded. Not actually sure how to delete all the things in the chat. This might be an interesting question. Okay, so here we are. I am not at all clear on the best way to teach VHDL or FPGAs. I'm using a mix and match between me talking and talking you through how to do stuff, demonstrating how to do it on the Citrix server, and then having you do it during our time together as a lab. So and I have the same problem. I haven't ever, well, not for a while anyway, I haven't for a while taught any programming language. And to a large extent, VHDL is a programming language, all right? So, you need to understand the syntax, the rules that VHDL uses to compose itself. You need to understand the tools that you use to manipulate VHDL. But you need to understand at a fundamental level what it's doing. And what it's doing is quite different from any programming language you've used before. Any programming language you've used before has been a sequence of steps, one following the other. If you've done multi-threaded programming, maybe that's not quite true. There's complexity if you start using multiple threads. But in general, programming is one step after the other. VHDL is very different. What VHDL is doing is it's not executing on a processor, it's reconfiguring the hardware. And actually, that's a good point. Maybe I should talk, I'd forgotten about, I have some slides that talk about what the technology is actually doing. So I might shortly switch to those. I forgot to upload them into the materials line, but I'll find them and talk about them. So because VHDL is reconfiguring the hardware, it's not necessarily step by step. In VHDL, every equation or every line that you write, and there's some caveats to that, but every line that you write is happening at the same time. So it's not step by step. It's all happening together. And that really means lots of different things are happening at the same time. And it can lead to problems, and we'll see hopefully next week some of the problems that show up because of this. So what I'm going to be doing today, like I said, I just had this idea about I need to talk about the devices, and I'll bring those slides up. But what we're going to be doing today is I'm going to be talking through some of the syntax of how VHDL hangs together. In particular, I'm going to be talking through some code that was auto-generated in Quartus. And I'm going to, next week, in next week's lab, I'm going to get you to do that auto generation yourself for the lab we're doing today. All right, today we're doing a lab where we're building a full adder. Last time we built a half adder. Today we're going to build a full adder. Not much different. And we're going to then be using that full adder component and compose it into a 4-bit adder. So a full adder just does 1 bit's worth of addition, whereas a 4-bit adder obviously adds 2 4-bit numbers together. Okay, so that's going to help us move things forward in terms of understanding how VHDL hangs together. Okay, let me, like I said, I just realized that I should talk through those slides. I meant to talk through them a while ago, but I forgot. Let's see if I can find them. That's that one. There we go. So, and let me just put these into the Discord channel for materials so that you've got them too. Okay, let's go full screen. Okay, and again, my thanks to Professor Jasmine Banks at QUT. She was kind enough to share her slides about VHDL. And I think we've talked about that before, right? VHDL is a very high-speed integrated circuit hardware description language, but they keep VHSIC as an acronym and just go with VHDL. Right, and here's a simple example where we've got an AND gate and an OR gate, and we can compose them together. Is that the right one? Sorry, I got the wrong one. This is VHDL intro. I think we did that. It's that one that I wanted to open. Let me just check that I put the right. Oh, I put the wrong one. You might as well have a look at that. There's no harm in having that intro as well. But let me just move the one that I actually wanted to speak about here. Okay, let's try that again. Sorry about that. So these are just details about devices that I really don't want to talk about. Where I want to get to is here. Okay, so you've all played in 363 with 7400 series devices, right? They're discrete, usually SSI, small scale integration, devices, individual and or not gates, exclusive or, NAND, NOR. Usually, if you're using logic, you generally want to do something a bit more complicated than just a single AND gate or a single NOT gate. So there's a way, rather than having multiple chips to implement a relatively simple logic expression, people have come up with two distinct ways of doing that. One of them is PLDs, Programmable Logic Devices, and the other one is FPGAs, Field Programmable Gate Arrays. We're going to be focusing primarily in this course on field programmable gate arrays, but it's worthwhile understanding how these devices work, because sometimes an FPGA can be quite a bit more expensive than a PLD of either type, and you're better off just using a PLD to implement the logic rather than going all to an FPGA. Right, so there's the acronyms spelt out. Simple Programmable Logic Device is SPLD. CPLD is Complex Programmable Logic Device. And FPGA, as I said, is Field Programmable Gate Array. So this is a way to think about how this works. Right? So what a programmable, a PAL, a programmable array logic does is it says, okay, you have a lot of inputs and you want to generate an output, and the way you usually represent the relationship in Boolean algebra is in a sum of products form. Does everybody remember what a sum of products form is? Let me just so Abraham, do you know what a sum of products form is? No? Let me see if I can tag someone else. David? Any thoughts on what a sum of products form is? Oh, you might be, you told me you're being communicator. That's okay, I'll move on. Any thoughts? Okay, I'll open it up to the floor. Does anybody know what a sum of products form is? Nobody knows what a sum of products form is. That's... Oh, I forgot to... Someone answered? Oh, really? Okay, maybe my... over voice. Okay, for some reason I'm not getting voice. Can somebody just keep talking and I will see if I can debug my voice. Let me just disconnect my voice. And I'll connect again. Can somebody say something? Oh, this is no good. Let me just... Somebody say something? Oops. Okay. So maybe I can't... everybody can obviously hear me, but I cannot hear anybody. I don't think so. I can mute people, but I can see right, I can see some people are unmuted. Jacob and Javier are unmuted. Sorry, I shouldn't probably show the class list on the screen, but anyway. Let me just go into Discord preferences and see if I can check my voice and video. Testing, testing, 1, 2, 3, testing, testing. That looks okay. Testing, testing. And that's my video, that looks okay. My volume is good. Ooh, I wonder if it's down here. Yeah, I just did that. Yasmin, thank you for the... that's what I was just playing with. Let me try it again. So where are we? Voice and video. So let me try that one, and then I'll change it back to external microphone, and then I'll change that to... Can somebody try saying something again?
Hello, Professor.
Hey, now I can hear something. That's on my speakers. Let me see if I can get you back on my headphones. Try again. Okay. Let me put you through the speakers and see if that is any good. For some reason my mic is not coming through. Can somebody speak again? No.
Hello.
And again. Ah. Let's try that one. Say something.
Hello.
Yeah, that's good. Okay. I'm going to leave it like that. It's not the best, but yeah. Thanks, Yasmin. I'm wasting too much time with my audio. It's funny. I've been teaching at Fairfield, and there it's a bit more difficult because I have half the class in class and I have half the class doing it remotely, and we chop it. There's 2 sessions a week and we change. But audio has been the hardest thing to get right because I either get echoes or feedback, or I think I've got it sorted now because I like writing on a blackboard, right, or a whiteboard, and I've never had to do that. I need to bring up the OneNote because I do want to write on the whiteboard. So did somebody say something about knowing what a sum of products was?
Yes, somebody did.
Okay, can somebody, whoever it was, come on and tell everybody? Or tell me, rather. I didn't hear it before.
Your stream also ended.
Okay. Sorry, I'm just getting myself organised. I should have been organised before. So let's do this. So remember, and they're the notes, right? And let me just okay, let me try this. Put that up there. So sum of products there, and draw. Let's go with just the white one. Right, so normally you get something like x equals a, b, c, or a, b bar, or d, right? And this is sum of products.
Professor, you may want to turn the stream back on in Discord.
Oh, in Discord? Okay, sorry.
Yeah.
Yeah. Good idea. Sorry about that. I forgot because I'd logged off. Where's my projector output? There we go. Sorry about that. Okay, so here's the that'll teach me for not being organised in the morning and checking my audio. I'll get to the bottom of that later. So this is a way to write sum of products, right? And it's a misnomer because this thing and this thing are not actually plus signs, right? They're or. And this isn't a product, it's anding those three variables together, right? But it's called sum of products, or SOP, right? And what these PLAs, right? Actually, this is PAL, Programmed Array Logic. PAL. What they do is they make implementing a Boolean expression expressed as a sum of products ludicrously easy. Okay, so let's go back to the slides and see what I mean by that. Right, so here's an example, and let me do this. Let me insert it in here because I do like drawing on it. Insert, print out, full. We want SU, logic design, that one. I think that's the one I had. Let's just wait for that to get inserted. I'm inserting it into OneNote so that I can write on it, maybe. Again, I should have been a bit more. There we go. Right, so let's zoom in. Okay, there we go. Eventually. There. Right, so, and let's get back to my draw menu. And let's go with blue. Right, so here, this is a 2 variable PAL, right? And you put in A and B, and even though it's not actually shown here, what's happening is the actual input comes in for A comes in here, and then it auto generates A bar, right? And the same with B. Okay, and then here are our products, and here is our sum. And these things here, let me see if I can get a bit thinner. These things here are fusible links. And what they do is they connect up or not each of the either A or A bar or B bar to each of these inputs, right? So the beauty of that is you figure out what, maybe this has got to be AB, maybe this has got to be A bar B, and maybe this has got to be let's just go with AB bar, right? So what that means is on this one we want A on one and B on the other, so we fuse that one to get A, we fuse that one and that one to not get A at all, and we pass current through them to remove the link, right? And therefore the only links that now exist are, oops, I did the wrong one, sorry, I should be actually thinking while I'm doing this, right? So the only links that exist now are those two. Similarly down here, the only links we want to exist are that one and that one. And here the only links we want to exist are that one and that one. And then we fuse all the others. Right, we get rid of all these other links. Usually, I don't know what the current technology does, but usually fusing those links involves connecting the chip up to a programmer. That programmer applies, it used to be a 12 volt voltage supply, which is way higher than most logic likes, and that 12 volt supply allows you to fuse all of those links that you want to fuse. The upside of this is now you have one chip instead of, well, in this case it would be two, right? You'd use a quad 2 input AND gate, and you'd then also have to have an OR gate. But if you had a quad, maybe it wouldn't be quad if it's 3 inputs, maybe it's only a 3, you'd be, in this case, you'd be wasting one of the ANDs. And in this case, if this was a triple, you'd waste 2 of them, or if it were only a double, you'd waste, again, one of the ORs. If you were implementing this in discrete logic, 7400 series devices. So you can halve the number of chips you need, right? Halving the number of chips means you can make it smaller, you don't have to pay for it as much, etc., etc. It's mostly good. Oh, and I didn't realize there was the answer, right? So the aim is to keep all of those links, and this isn't quite the one I did. I did A bar B instead of A bar B bar, but that's the same example. Right, you can do the same thing, and now this is a way to do the same thing, but now you can reprogram it, right? The problem with the previous device is the PAL is once you've fused those links, it's done. You can't change it. The nice thing about a generic array logic device is it does the same thing. It's, you know, allows you to reduce the footprint of the number of devices that you've got, but now we can reprogram it. So if we make a mistake, we can redo it, or if we want to reuse the devices, we can reuse them. Where am I going? I drew that one. Okay, so input buffers are needed since one input must drive many. I don't know whether you came across in 363 the idea of fan out. I believe I talked about it earlier. Right, so the fact that you've got, let's go back to this one, right? The fact that you've got one input potentially going to 3 devices means that you're using up some of the fan out from this signal, right? If you were using that signal outside of this device elsewhere as well, then you've got to take it into account in terms of the fan out, right? And so that's why this is the way that I think I drew it up here somewhere. Yeah, right. I drew it like this, but the way it's actually done is like this. So you've got a buffer, right? So instead of this external signal A coming into here and going to 3 devices potentially, this external signal A is only going into a buffer, and that buffer is it's only one device, right? And so we write, right, we draw a NOT gate like this. So if this is a 1, this is a 0. A buffer is the same device, except it doesn't complement the logic, right? It just transfers the logic from one side to the other, and the aim usually is to do with fan out or sometimes isolation. Okay. And there's some example devices. We're not going to be using the example devices. Right? So sometimes these devices can be rather complicated, right? You can do lots of things. I don't know whether you can quite see it, because it's pretty hard to see, but all of those little bubbles there are potentially AND gates, and that's one big OR gate, right? And then you've got, how many we've got on this one? We've got 10 of them on this one, right? So it's quite, you can get quite complicated logic on these devices. Now, what did I want to talk about? I didn't want to talk about these specific devices. I wanted to get on to that's just a way to configure them. Right, these devices are useful for some small logic applications, very simple stuff, but they're quite limited. And as it says there, you can't really make a ripple counter or something like that with them. Right, here's another way to do it, where you have the buffers on the inputs there, and you have an array of AND possibilities, and then you have a programmable OR possibilities on the other side. Right, so this one is better for scalings, right? So you can have 4 inputs and lots of outputs. And in this case, you just keep the appropriate connection on here, and effectively that gives you an AND of whichever connections you've left. And then you keep the connections that you want down any one of these columns in order to OR those product terms into an output. And here's the more complicated version. Right, here we've got this is what the complex programmable logic devices look like. And I'm not going to talk about these ones explicitly. I've dumped these notes for you. The thing I wanted to talk about though are the actual devices we're using, which are field programmable gate arrays. Right? An FPGA is an IC, integrated circuit, that contains an array of identical logic cells with programmable interconnections. The logic cells are called configurable logic blocks. The array of configurable logic blocks is surrounded by I/O blocks, which connect to the configurable logic block signals, to the IC, the integrated circuit pins. Okay, so here's an example of the structure. Right, so it's quite a complicated beast, and remember the example we did last week, which was just the half adder, was deployed onto this sort of device, right? Or this sort of device, I suppose, is more pointing the right direction. I don't know about you, but that would completely freeze my brain if I had to figure that out. That's why when you're dealing with FPGAs, you have to use a compiler, right? And that's effectively what we're doing. I don't know whether that compiler is the name they use. I think it is. But you have to compile your VHDL code, and that takes your VHDL code and maps it to all the different pieces in this, where is it? Up there. All the different pieces in the FPGA. Those configurable blocks on the FPGA is not as complex as in the CPLD. Sometimes the other so the other difference is, whereas what we just talked about with the PALs and the CPLDs, they're all based on sum of products. whereas FPGAs are based on lookup tables. Let's see if we've got something about lookup tables. Right, so there's a slight zoom in onto the CLBs, the configurable logic blocks. And here's a here's the logic module. So let's just go back there. So there's the logic module, and you can see there are a few of them in each CLB. And oops, not sure why that didn't move properly. No, it's just stayed there. Okay, and here are our inputs. Right, and here's the lookup table. So we get a sum of product output from that lookup table. Then we do some associated logic to get things in and out of the logic module. Right? The lookup table is like a truth table. Right? It stores the sum of product result of the logic function. So a lookup table is basically a right. You know what a truth table is. You've got 0, 0, 0, 1, 1, 0, 1, 1. And then this is the whatever's in here, let's call it W, X, Y, Z. These values here are the values of the lookup table. Here's the input for the lookup table. Here's the output for the lookup table. This is what is being looked up and presented as the output. Right, and this is the detail of that. Right, here we've got just a 3-bit version. So this is like a multiplexer, and it tells which of these outputs is the right output. And here are the entries. Right, here's W maybe. And these blue blocks are memory. So the lookup table has is partly just a memory, and the values that you want in that truth table are just stored in those memory cells. And I don't want to go into that too much. Let's see. So one of the things that is nice about FPGAs is sometimes there's well-known complicated logic that you want to do, and chip manufacturers make that well-known complicated logic easily available by hard coding it in some of the logic blocks, right? So you don't, those logic blocks are now not programmable, but they do stuff that's useful, often useful, and it's available. So in this example, the yellow blocks here are hard coded. They only do whatever the function they were coded for, and all these other blue blocks are programmable by the user. So there's still plenty of variation available. Okay, so the advantages. You can do lots of quite complicated tasks in FPGAs, right? I don't know whether I showed you the example. Let me see if I can pull it up quickly. I think I probably did. Right, so this is this was a while ago, but I've using an FPGA to generate VGA video. That's my old VGA monitor, and that red box that's traveling across the screen is being generated completely by the FPGA, right? There's 5 control signals in there's 5 control signals in VGA. I think there's horizontal sync, vertical sync, red, green, and blue. Right, and in this case it's just the red version. And let me just put that video into the contents. Sorry, I forgot to put the Discord chat back on. Sorry about the forgetting to put the video back on. So where are we? Constant. I'll put it in the links. Okay, so there's the links for that video. Okay, and this is just going through, and this might be a little old. You can actually get quite cheap FPGA boards down to about $12. Maybe that's not that cheap, but these ones do some useful things. But have a look at the number of logic cells, right? This one, 256 logic cells, whereas this device here, 24,288, right? That's quite a few logic cells. I'm not sure why the drawings are staying there. That's a bit odd. Anyway, there we go. Probably something to do with me streaming this screen. So, and I think that's about what I wanted to talk about as far as the devices are concerned. Okay, anybody got any questions about what I was just talking about the... So that's just a little bit of background about what sort of more complicated devices are available in logic, and particularly about the FPGAs we're going to be using. You don't have to get in there and twiddle bits on the FPGA like you do on a PAL. On a PAL you've got to decide which of those fuses to fuse, or you've got to decide which of those connections to make in the more complicated version. The FPGA, we're going to program it, and we could program it in Verilog, but we're going to be using VHDL. The two, I haven't quite figured out which one's more popular. I think it's about 50-50 at this stage. But learning VHDL will get you at least the concepts that you required for Verilog as well. So, in fact, I had only programmed Verilog very recently with that one of those test module that I got you to try and execute or try and compile as one of the first labs here. Okay, where was I? That was more of a diversion than I was expecting, right? And let me just get out of that. Get out of that. So I've shared those two PDF files from Professor Banks with you, so please have a look at them. The one I talked to was the second one I shared. So let's go back to the slides. I didn't even get past this slide, so let's go to the next one maybe. Right, that's what we've got on the agenda today. Structural design and the 4-bit adder. I talked to this slide last time, right? The idea is you can either draw things like we did in multisim and draw the structure of the circuit, or you can write things out in a Boolean logic expression. You can get the behavior of the circuit. And we want to be able to define the interface into our circuit and out of our circuit. And that's defined by the port statement. Inside the behavior, the port statement is part of what describes the entity in VHDL. And so there's entity, you name the entity, then you define the port, which is the interface into that entity, and then the behavior of that entity is described in the architecture. Right, so that's the general form of any VHDL file. There's the entity that describes the system's interface, and we call the inputs and outputs ports, and that part of the VHDL is called the entity declaration. The architecture, this defines the system's behavior. It's separate from an entity, but it must be tied to an entity. So you need to tell, in the architecture definition, you need to say this architecture applies to this entity, right? And when you do that, then you can use the inputs and outputs defined in the entity to be manipulated inside the architecture. Those two, the entity and the architecture, are put together in the one text file, and the name of the text file should be the same as the name of the entity. Right, so in this case, the entity name would be adder, so the file is adder.vhd. I think I talked about those. HDL is not case sensitive. If you want to have a comment, precede it by, it should say preceded, not proceeded, with 2 minus signs. Names must start with an alphabet letter. No, that is not a number, but names can include an underscore, not 2 in a row, or as the last character, and names cannot be keywords like in, out, bit, etc. Let me see how much you know about compilers. So I think is that Javier, I think? Yeah, is that right? Javier, why would VHDL not allow underscores as the last character? Any ideas?
Would it just mess up the way the coding works?
Could you say that again?
Would it just just mess up the coding of it, so it just does it allow underscores it does allow the underscores. I'm not sure, honestly.
You're pretty close. So one of the things that compilers do, regardless of the context, whether it's C or Java or C# or VHDL, one of the things that compilers do is they have to make up temporary names. And one formalism that some compilers use is they say all the temporary names that the compiler is generating may have an underscore at the end. So the reason why they're banning underscores is because if they didn't, it's possible that you would name one of your variables as the same thing as something that the compiler may auto-generate. And to avoid that name clash between the generated name from the internal to the compiler and the one that you decided to use, they've forbidden that form of name. And so that's why that mechanism for generating internal names is different by compiler. That's why sometimes you don't see something like this as explicit in terms of banning underscores at the end of names, but that's part of the reason why they do that here. Okay, where are we going? There we go. So let's try that. And right, the entity name, the signal names, the signal type, and yeah, we've done this before, so I'm not going to talk too much about that. There's an example for the adder, and that's the architecture. The architecture can be quite a bit more complicated, right? There's a name, there's the name of the entity that you're defining the architecture for. Both of those things have to be there. Then there's a whole list of optional items: types, signals, constants, functions, procedures, components, right? One of the things we're going to have to do in the lab today is we're going to have to use predefined components. We're going to define a component called the full adder, but then we need to create 4 instances of that full adder in order to make a 4-bit adder. And so for the architecture of the 4-bit adder, we're going to have to define those full adder components, but we'll get there. Right, so that's roughly what an architecture statement is. Architecture, name of the architecture, of the name of the entity is, then all the predefinitions, then the actual behavior or structure between begin-end architecture. Okay, and there's some examples, right? That's the first one is an example of the AND operation for a 2-input AND gate, and the next one is an example of an addition operation between 2 inputs. So you may have come across if you've done any programming, you may have come across the idea of strongly typed languages. VHDL is a strongly typed language. So you cannot assign a value from one type into a variable of a different type. The type of the assignments on both sides of the assignment operator have to be the same. For example, you can't add a string to a real value, right? You can't add a bit to an integer. There are ways to convert from bits to integers, because adding a 0 or a 1 to an integer may be something you want to do, but you can't just put the integer variable and add the bit variable to it. You have to do the conversion first, but we'll talk about that later. Right, there are some predefined functionalities. You can add integers to integers. You can't use it for bits. And yeah, let's. I'm just going to pause here. So I'm going to talk about the IEEE packages, because most of what we're going to do is going to use the IEEE package. There's some nice stuff in there that makes our lives a little easier. But before I do that, I'm going to take a 5-minute, maybe a 10-minute break. But before I do that, does anybody have any questions about where we are so far? No? I
just have a question. So, is the test on the horizon, or is that more far out?
The test is on the horizon. That's a good question. When should the test be? Right? What page was that? Let me just get my page back. That is page 20. So where did we say the test would be? I didn't. So what I would suggest is that we aim to have the midterm around about the week of October 10th. That means next weekend, and let me, I don't have my notepad, I'll grab my notepad during the break. That means next weekend I will release the exam paper. If you haven't done an online oral exam with me before, the way I do it is I release the exam paper preferably 2 weeks, sometimes it's only a week, preferably 2 weeks before the exam time, and that way you know precisely what you have to answer. It doesn't necessarily help, I'll tell you. You need to understand what the questions are asking. I'll release that, and then I'll release a series of times. We will still be having the lectures, right? So the exam, the midterm exam, will be at a time of your choosing, mutually agreeable with me, and I'll put the appropriate available slots into the bookings sheet, that web sheet. I don't want you to use the general consultation booking. That'll be for general consultation in case you need to talk to me about questions about the exam before the exam. But I'll make those available. You should make sure you're available for up to half an hour. Usually the orals that I've been doing only take between 5 and 15 minutes. And it's funny, sometimes the 15-minute exams score lower than the 5-minute exams. It depends on the student and depends on the exam. That was a very long-winded answer, but does it answer your question? You're welcome. Okay, so let's take a 10-minute break, and I will be back after the 10-minute break. I'm just going to put the mini-me away, and I'll put myself on mute in Discord as well. Testing. That should be okay. Okay, let's get back to it. So, does anybody have any questions so far? I've put my hearing aids back in, so I won't have to lean quite so much to hear you now on the speakers. I'm not quite sure why my headset isn't working, but I can hear you on the external speakers. I'm still using the close talk mic, so hopefully that'll be okay. Let me just put my phone up here and bring up the Discord chat so I can see it. Okay, let's get back to, where were we? Page 20. You've already seen this in the lab last week, right? There's a IEEE library that's quite good. The syntax is library is the keyword in VHDL and then the name of the library, and then you use particular parts of the library by accessing it via dot notation. That's similar to the way Java or C# works, or even Python as well does something similar. The usual parts of the IEEE library that we'll use, the one we'll definitely, and we have already used, is the 1164 part, which allows us to use some of the standard logic types. But then there's also an arithmetic part that lets us do addition and subtraction on different types, and then there's a signed version. Most of the addition and subtraction is on unsigned integers, so everything's positive, whereas the signed version uses, my guess is 2's complement representation of negative numbers. So let's tag somebody again. So Quinton, do you know what 2's complement means? No? Okay, I'll move on.
Sorry, I was a little excuse me.
That's okay.
Muted. Sounds familiar. I don't know if something with some binary. That's why I can remember some of the remainder, maybe.
Right.
Like something with carry. Like
very, very, very close. So let me just go back up here and let's go here maybe. Let's just make another page just so that I can write stuff. So 2's complement. Right, let's start with 1's complement. Right, 1's complement, if you have a number 1101, then the 1's complement of that is 0010, right? You just bar or complement every item. 2's complement is similar, in that you do the 1's complement, but then you add 1. Okay? And the reason you do that is there's a relationship between these two numbers. And as you know, or you should know, this is the binary representation of 3, whereas this is the 2's complement representation of -3. And the idea is that if you add them up, right, 1 and 1 is a 0, carry the 1, 1 and 1 is a 0, carry the 1, 1 and 1 is a 0, carry the 1, 1 and 1 is a 0. There is a carry overflow, but we ignore it, right? So that's just saying that 3 plus -3 equals 0. So that's what 2's complement is about, right? It's the 1's complement of the number plus 1. And the reason we use it is because it gives us a way to represent negative numbers using binary notation. Right? And that's why this signed piece is there. That allows us to do signed arithmetic rather than just unsigned arithmetic. Okay, let's move on. So here's, we've seen this before, it's putting it all together, right? For this particular one, I don't think you actually need these two items here. I don't think they're required. No. And here's another one, and they've pulled out the two pieces that are not used. There is effectively a standard VHDL library, but you don't have to explicitly call that in. You do have to explicitly call in the IEEE library. Now, I'm going to continue with the next slides, but I could go back and I will show you how to get there. Right? So if you remember, actually, let's just see if we can pull up Lab 3. I should have started the app server earlier. I'm just going to go back and look at the VHDL code that we put together for Lab 3, which is due 11:59 p.m. tonight, in case you don't remember. Okay, we want quartus. Here we go, that'll do. It might take a while to start up. No, that wasn't too bad. And I'm just going to bump up the sizings before we get too far. That might be a start. No? That's better. Let's open a project. And I'll try and get access to it on my local machine. Tried to put in a quick link, but for some reason the Citrix server doesn't see it, so I have to do all this navigation. I think it's that one I wanted. And I need to, somebody's not on mute. Let me just see if I can put everybody on mute. Javier, I put you on mute, but you won't be able to unmute, so text me if it's a problem. And there's tools, options. Okay. It's just you're looking like you're unmuted here, so there's that. General fonts, I changed that. I've forgotten how to change the editor font. Okay, let's have a look at the half. Maybe it's in here. Customize, maybe. Text editor. Custom, no, that's not what I wanted. I have forgotten. How to change the text editor to make it bigger. Got everything else. That's the toolbar. Any thoughts on how I changed the I thought it was in there's no preferences there. Options? Text editor, font, that's the one. Why didn't that come up before? Okay. There we go, maybe you can see it a bit better. Right, so there's our, that's the one I did live last time. And one piece of feedback for some people for Lab 3, you didn't get full marks because your adder, half adder, didn't half add. It just gave 0 on the sum and 0 on the carry. So you actually do need to change the code that is in the Lab 3 statement and to actually have it do something, and the answer is there on the screen now. I'm not going to, you might have to type it out, I'm not going to make it available directly. Right, so this is the half adder, and we can hit the compile button. If I can figure out where the cursor got to, there we go. We can hit the compile button, and that's going to take a while, but it will go through and compile and everything will be happy. But there's a few things we're trying to do here, right? One of the things we're trying to do is to compile VHDL. And that's what's happening now. So I think we're pretty good with compiling VHDL, and I think most people have actually managed to compile VHDL either locally or on their on the Citrix server. I'm running on the Citrix server now. So the next thing, if you're actually building something using VHDL that you want to do, is you want to test it. So does it actually do what you want it to do? And we're not going to do that today. Well, that's going to be the lab next week. But I'm going to show you how we go about testing it. So I'm talking about that a little bit today and more next week. And then the final thing is, once we're happy that it's tested, we deploy it. Right? So I think we should be okay with compiling VHDL. You are going to have a lot more errors once you start modifying or writing your own VHDL. That's just par for the course. So start reading about VHDL, and I'll be online. We can sort things out, syntax errors and all that sort of stuff. But these are the 3 steps we need to go, and that deploy means we need to go to an FPGA. Now, a while ago I asked everybody to fill in a quiz or a questionnaire about what you've done, and I'm going to be getting 12 people to pick up the FPGA boards that I have. I already have given away 2 of them, so I'm going to be getting somebody who's running Quartus, Model Sim, and has the Cyclone 4 library installed, and I'm hoping I can find 10 of you. Then what's going to have to happen is, once we start doing the deploy labs, you're going to have to do those deploy labs in groups. 1 person in each group should have an FPGA, and there's only 12 FPGAs, so we might have to have some groups of 3 people. Everybody okay with that?
Yes.
Okay, good. So what's the best thing to do now? So I was going to talk to this inside PowerPoint, but it might be, now that I'm here, I think I might just as well do it within Quartus, because it's better to have the syntax highlighting, because it's easier to see what's a keyword, right? The way you do tests in Quartus is as follows. You go to Processing, Start, and then you hit, I didn't realize it was still compiling. It's still compiling, it's only 39% done. If it were not still compiling, that Start Test Bench template writer would be ungrayed out, and I'd be able to run that. And I have already run it on this project, so I'm not going to rerun it. I just wanted to point out where it is. And let me just take a screenshot of that so I can put this into the notes. In fact, let me just add it to the materials section, just so that I know where it is. Okay, so that when I do that, and I will, once it's finished compiling, I will do it on a clean project. What it does is it generates this subdirectory inside your project, and then this subdirectory inside your project, and then you've got to select the right file, and lots of files. The particular file you're interested in is the VHT file. Right? That's the one that is most useful. And that VHT file for this particular half adder looks like this. Right? We have an entity description. The entity description has no ports. What we're going to be doing is we're going to be taking this VHT file and simulating it. VHT files are like a wrapper around the things that we're trying to test. Because they're a wrapper, they don't have any inputs and any outputs, so there's no port statement. It does have an architecture statement, but then because there's no port statement, now we have to define the signals we're going to use, the internal signals. Well, they're signals that are internal to the half adder VHD test entity, but they're external to our components. Right? Then we define a component we're going to use, and this name, half adder, has to exist as a top level entity in one of the VHD for dog files that are part of this project. We already made the half_adder.vhd for dog file, but we need to make sure that the names match. And here is this should match the port statement in our component. The reason why this has another port statement, I believe, is maybe not. Yeah, I'm not quite sure. Let me in fact, I needed to make a note about our exam. So this is CET466 on the 19th, and the first thing about it is the midterm, and I will release that next weekend. And then the next one is port statements. I will find out about port statements in component sections. What I'm not sure about is whether the port statement here has to match precisely the port statement in the entity description of the half adder. I believe it does, but I'm not sure, so I will check. Then the the architecture begins. So this begin statement, let me just write it in. Is the beginning of the architecture. Right, of half adder arch up here. And the first statement here is the way you get an instance of a half adder. Right, this is a declaration about saying, okay, I need a half adder. Even more than that, you'll notice that there's no semicolon here, right? The semicolon is down here. What we need to do is we need to make connections between the instance of the half adder and the signals that we've defined. It's a bit confusing because we've defined the names of the signals within our half adder arch architecture to be the same as the names of the signals on our half adder device. But these are different from these. And the way we make them the same, because we do want our signals to go into the port or come out of the port, the way we make them the same is through the port map statement. Right, so here's a map from the port to a signal, the map a port to a signal, the map a port to a signal, and it's just, it's a bit silly. It's just saying A goes to A, B goes to B, C goes to C, S goes to S. But really, the left-hand side A, B, C, S are very different things from the right-hand side A, B, C, S. Okay. Because this is a test harness, another name that sometimes you see in here, instead of I1, which is just instance 1, sometimes you call that UUT, unit under test. I'm just going to leave it for now, but sometimes it's best to name the thing you're testing very clearly. I1 is very generic, it's not very clear. So the next piece is a process. Now, I have said that over here, back in the VHD for dog file, these things are not happening sequentially. They're both happening at exactly the same time. S is being calculated and C is being calculated. And we can, after having looked at the FPGA architecture, you can understand why. This VHDL is being compiled into an appropriate lookup table on the FPGA, and that's the first one. The S1 is being put into one lookup table, and the C1 is being put into another lookup table, and they can both happen at the same time. Right? Now I'm going back on my word. Now what we're doing is we're grouping together statements that need to happen sequentially into processes. And this is another VHDL keyword, process. And anything between the begin and end statement of a process has to be done sequentially. This The outline of this VHT file, VHT for Tom file, was generated automatically, and this init process was there, and so was this statement, code that executes only once. Right? Sometimes when you're doing a test, you want to do the initialization. And that could be anything. That could be setting variables. Maybe we want our initial logic values to be something. So perhaps what I could do initially is in here I could say, you know, A goes to 0 initially, and B also goes to 0 initially. And that would be their initial conditions for the start of the test. I'm not going to do that. In this particular case, because it's such a simple device, I don't have to set stuff up, so I'm not going to. After that process, there's the first process, there's another process. And this is the process that actually executes the test. Now, you can see all this code here. I wrote this code. This code was not auto-generated. I had to type it in. One thing I didn't say in the process, this init process definition doesn't have any parentheses after the process statement. That means the process statement executes once but all the time. The reason this one executes only once is because of the wait statement. As soon as you hit that wait statement, this process is hung. It's not going to do anything else. An optional thing you can add to a process statement is to tell the process when to run, right? And that telling the process when to run is called a sensitivity list. That's why it says optional sensitivity list. That sensitivity list could be a variety of things. It can just be a variable name, or it can be, say, this only happens on an edge of a variable, so when a variable changes. You can say on a positive going edge or a negative going edge. Sometimes that's needed. But for our example today, we don't need a sensitivity list, so I haven't filled one in. And right, the end of the process is down here. The process, once the process has done this stuff, it's not going to do anything else, so it's just going to hang. And there's the end of our architecture, which was started up here on line 33. Now let's have a look at what's happening. And I'm going to ignore the asserts for now. So what's happening now is we set A and B to 0 and we wait for 100 nanoseconds. Then we set A to 1 and B to 0 and we again wait for 100 nanoseconds. Then we set A to 0 and B to 1 and we wait for 100 nanoseconds. Then we set A to 1 and B to 1 and we wait for 100 nanoseconds. Okay? So what that's doing is, remember, A and B, we can scroll up, A and B are the inputs to the unit under test. Right? So what we're doing is we're going through all possible inputs for the half adder, all values of A and B, and now we can talk about the assert function. We're checking that the outputs S and C have the right value, right? So for A and B both 0, the outputs should be both 0. So this assert statement says, if the following Boolean statement, the following conditional is false, report that the sum is incorrect 0, 0 with severity error. The next line is saying check that C is 0. If C is not 0, so if C equals 0 is false, say the carry is incorrect for 0, 0. So what will happen is an error will be generated if there's an incorrect output, which is kind of cool. These things here, these are just print statements, right? I said that the assert only does the report if the condition is false, and I'm just setting the condition false. So this is like saying print lots of equal signs. The severity, there's a variety of severities. Error is the highest, note is the lowest. For this one, I'm only interested for these three, I'm only interested in notes. And for the ones at the bottom, I'm also only interested in printing stuff out. But the aim is to say this is the start of the test, this is the end of the test. Okay? Any questions about what I've just talked about? Okay, looks like our compilation has finished, thankfully. That took 8.5 minutes, which is pretty long. I have a really old low-end laptop and it doesn't take that long. So remember what I suggested? Processing, start template, test bench template writer. Right, and my lovely code got blown away. Right, this was the code that had the all those weights and asserts and settings in it. So now you can see what the template generates. Mostly, the only thing you will have to do is to fill in the bit between the begin and the wait on lines 67 and 69. Okay, let me just see if I can... Right. Everybody okay with that?
Wait, how did you bring that up again?
How did I bring it up?
Yeah.
Okay, so let's say we've just got our VHD file and we want to generate that test bench. Then we go processing, start test bench template writer. processing, start test bench template writer, and it will generate the that test bench. And it's thinking about it. There we go. And then where it puts it, you should be able to see right? You should be able to see in the output where it put it. It's going to be in the generated VHDL test bench file, and then this excruciatingly long path because of I'm actually saving it on my local machine, connected via the Citrix server. So it's in the lab, the project directory that we were editing the VHD file in, but in the subdirectory simulation model sim. So let's go and open it up. So there's the simulation, there's model sim, and there's all sorts of stuff in here, but it's the .v for Victor, H for Hotel, T for Tango file, VHT file. That's the template file. And there it is. And what I'm just going to quickly go through and set up A is 0 and B is 0, and then I'm going to wait for 100 nanoseconds, and then I'm going to assert, and what I'm going to do is I'm going to assert the wrong thing, right? I'm going to assert that the sum is 1. It shouldn't be 1. What I want to do is I want to generate a report. Okay, we have a template file. Now there's still a few other things we've got to do. One of them is under Tools, Options, actually we do need to do that one, but I think I need to do it differently first. I need to go to so I'm back on the project. I need to go to Settings, and then I need to scroll down, and I need to do a simulation, right? And normally this is set to none, right? I need to make sure that my format is VHDL. I need to make sure the tool name is Model Sim Altera. I need to make sure the output directory is Simulation Model Sim. Those should all be set up for you. What you have to do is to change the name of the test bench, and I've already created it here, so it's already here, but what you will have to do is you'll have to say new, name the test bench, browse for the VHT file. Oh, that's right. What you got there, Way? Can't generate. Ah, yes. Well, that's the other thing I need to tell you about. So let me get there. Okay. One minor problem with this particular piece is, I don't know why, but this dialog doesn't let me access the networked files on my local machine. So I had to copy everything up onto the Citrix server first before I was able to add the file here. I've already added it, it's already there. But what you'll have to do is you'll have to go here, navigate to that Victor Hotel Tango file in Model Sim, in Simulation Model Sim, and add it to a list, right? Which is what I've done here already. Okay, so that's one thing you've got to do in order to do this. You have to tell it to compile the test bench. Let me deal with Way's question, right, which is in the discussion chat, and that is, it's erroring out because you don't have a simulation tool selected. So you need to go to Tools, Options, and I'm going to try and get IT to set this up so it's fixed all the time, but I'm not sure I'll be able to do that soon. So you will have to do this if you're running on the Citrix server. Even if you're running on the on locally, but if you're running on locally, once you do it once, it's done. Whereas this one gets reset every time, so it's a bit painful. So you need to go to EDA Tool Options, and then I think it's that one, but I can't see the name fully because I have, actually maybe it's that. Let me just have a look at my local machine here. Tools, Options, EDA Tool Options. Yeah, it's the bottom one. So it's the this one. If this were expanded properly, it'd say Model Sim Altera, right? And what you've got to do is you've got to tell it where the Model Sim Altera executable is. You shouldn't have to know this, but you do. On this machine, the Citrix machine, it's under OS Disk C, Programs, Altera, Model Sim _ ASE, Win32 AL OEM. Right, that's the full thing, and I'll put that in the discussion. Local installation of Model Sim Altera or Quartus. This is in Quartus. It will save automatically, so you won't have to do it every time. I'm going to see if I can get in contact with IT again. They only told me yesterday that Model Sim was installed on the Citrix server, so I tested it out last night. Okay, Wei, I hope that fixes the problem for you.
Actually it didn't. So on my C drive, there's only program files and program files x86. There's no just program.
Oh, are you running locally? Are you?
Yeah.
Okay, so you'll have to go to there should be depending on how you installed it, you should have to go to the top level and look for an Intel directory. If it's not there, there'll be an Intel directory inside either program files or program files x86. Let me just check. Yeah, on my installation, it installed on my laptop over here. It installed Model Sim Altera inside C:/Intel FPGA _Lite /20.1 Model Sim _ASE Win32 AL OEM. Does that help?
that's what okay, I got it.
You got it? Okay.
Yep.
Yeah, so the path that I put into the discussion chat is the path that you need to use on the Citrix server. Your local installation will probably be different, and on mine it just I didn't actually tell it to install it there. It chose it itself. It's at the top level. It's called Intel. Let me see if I can. I don't have Discord on my laptop, so let me just take a picture with my phone and send that to the discussion channel. It's taking a while. It's a 4 megabyte picture. Oh well. Okay, so they're the two things you've got to do. Now, before you can, there it is, before you can get run a simulation, after you've created the Victor Hotel Tango file, the template, you have to recompile. So I apologize for that.
Where do you have to go again to do that?
Sorry, to go to do what?
To
Put in the path. To put in
Yes.
the path, you go to Tools, Options, and then you select EDA Tool Options, and it should be the bottom one here. I can't see it. Let me see if oh, there we go. There we go. So it's Model Sim Altera is the thing you're looking for. Okay?
Thank you.
You're welcome.
Do you know when Model Sim will be added to the virtual machines?
I am running on the virtual machines. It is there now.
Oh, okay. Thank you.
Yep, you are. No, I wasn't going to tell you about it until it was available on the virtual machine. So they told me yesterday afternoon that it was available, and I spent a little bit of time last night just checking that it all hangs together, and it seems to be working correctly. Like I said, the only slight glitch is it doesn't save the configuration. So every time you need to use Model Sim, you'll have to set this EDA tool option to make it available. Okay.
Professor.
Yeah.
So I changed the path, but I still have the error showing up. Can't generate test branch files.
Okay. Let me just read your error again and see if it's telling me anything else. Okay. Maybe let me just continue with what I'm doing, and let's try and during the lab session, I'll get you to share your screen later, and we'll get to the bottom of it. Okay. There's still a few things I want to talk about for the whole class for now. Okay.
All right. Thank you.
You're welcome. We'll get there. Okay. So. Oh, there might be something else. Sorry. Where is it? So I'm hoping you selected EDA tool settings simulation Model Sim Altera. That might be the other place that you've got to select it, Wei.
Where is that located?
So you go up here, right click on it and select settings, and then go all the way down to EDA tool settings simulation, and then you need to select the Model Sim Altera option in the tool name. It's probably blank right now, which is why it's saying that you need to select a simulation tool. Okay?
Yes, yeah, it was blank and then I run it right now, it works now.
Okay, cool. Good.
Thank you.
Yeah, no worries. Sorry, I should have thought of that straight up. Okay, so anyway, we have a start of a test. This only tests one of the inputs and it's testing it incorrectly. But let's do the next step and actually, like I said, I've forgotten whether I hit recompile. I don't remember. I'm going to have to hit recompile again because when you change the VHT file or the VHD file, you need to recompile the project, right? Because I changed the VHT file. The other thing is in where was it? It was tools. Oh, it was where we were before. So settings, simulation. You need to select this compile test bench, right? After you've selected the simulation tool, you need to select the compile test bench and make a test bench, which includes the VHT file that we made, that we auto-generated. If this is selected, then when you compile the project, the test bench will also be compiled. I had a problem last night where it wasn't, the test bench wasn't showing up for me because I'd forgotten to do that step. Okay, what's next? Well, we need to wait for that to compile. Hopefully it won't be too much longer. I'm wondering whether the compilation is so slow because it's doing it over the network and saving it on my local drive. Anyway, I think I can start it anyway. When you do a simulation, you need to run ModelSim. So it won't let me do it because it's blanked out. The way you run ModelSim, provided it's selected in that options list, is you go Tools, Run Simulation Tool, RTL Simulation. Right? And it won't let me do it right now because it's in the middle of compiling. And it's got another okay, so you get a VT file rather than a VHT file. So what's happening there, right? And it won't let me show. Let me just I'll do it on my laptop. So if you go processing, start test bench writer do. That's not the place you set it. Right. It's what you've probably got there is under Tools, Options, EDA tool. Sorry, it's the project settings. What you probably got there is under Settings, Simulation. You probably have Verilog HDL selected instead of VHDL. I think Verilog HDL is the default, so you need to change format for output netlist. Yeah? Okay. Okay, no worries. And how's that going? It's probably got another 4 minutes to go. What can I talk about in 4 minutes? Oh, I know what I can talk about in 4 minutes. Not really directly related, but tangentially, right? I think I showed this before, but I'm going to show it again anyway, because this is the board that we're aiming to eventually deploy to. Remember those 3 steps: compile, test, deploy. This is the 3rd step. So this is the Cyclone 4 board. Cyclone 4 is a little old, but they do what we needed to do. And what I did is I took the half adder code, VHDL code, and I deployed it to this board. I'm just going to talk through it so we don't have the... And the push buttons here are the inputs, and the 2 right-hand LEDs are the outputs for sum and carry. So what you'll see here is if I change the inputs, right, there's the sum bit, the bit 4, LED 4 rather, and if I press the other one, the sum bit goes on. Then if I press both of them together, the carry bit comes on. Okay? And if I just get one of them, I can make the LEDs go on and off. Okay, so that's where we eventually want to get to, and we will see about getting there. Now, where did my Citrix server go? Oh, we're still about 1.5 minutes away. So I might try it out, running it locally next time. This is taking a little while. What we're going to do once it's finished is we're going to start up sorry, I'm just looking at myself on another stream. It's a bit distracting. We're going to start up the simulator, and we're going to get the simulator to run our test bench. And what you'll see is there's two main windows in the simulator. The first bit is all the setups, and then the second bit are the timing diagrams that show the values of the inputs and the outputs over time, and that's quite useful. We'll also have the assert report statements are going to be there as well, but they'll be in one of the output windows in the main model sim place. Okay, we're just about done. And maybe it's taking about the same amount of time. There we go. A little bit sooner, 20 seconds sooner or so. So like I said, what we've got to do is go Tool, Run Simulation Tool, RTL Simulation, and that should fire up Model Sim itself, and we should see a little feather type symbol down here. There we go, there's vSim. And here is the Model Sim. Here is the Model Sim window. Now what happens as soon as you start it up, it used to be that Quartus had some problems with Used to be that Quartus had problems with compilation, but the newer version is working better. But what it does is when you first start it up, it'll recompile it'll recompile for Model Sim the files that are being used. So what you can see here on the screen, again, it's a little small probably, and I don't know whether I can change font sizes and stuff. That would be a good thing to try and do, but I don't know how to do it here. So I apologize for the small size. Yeah, I'll leave it here for now. So when you first start this up, go to the Library tab and check under Work. And you should see at least two things. The entity that you created, the half adder in this case, and the test bench entity. You should see all of the entities in your project, but in this particular instance there should only be two entities. The one we want to simulate is the test bench entity. The reason is the half adder, we could simulate it, but it doesn't do anything, right? We don't set any values inside there. We don't set anything to the inputs. We don't set anything, do anything with the outputs. So we need to simulate the test bench. So to do that, you right click on it, and I'm going to recompile it just because I'm a little bit paranoid about compilation. Again, that's because I was using the older version of Quartus, which was pretty buggy, but this one looks like it's much better. Okay, so that was recompiled, and then you right click again and go simulate. And there is already a simulation. These are the simulation windows. So it's saying, okay, I'm going to close the existing simulation. Let's start it up again. And there we go. Right, and now in our objects window, you should see the signals that you're interested in, A, B, C, and S. Down here, remember we had an always process and an init process, and then it looks like there are some other things that count as processes that we didn't actually say were processes. I'm not that interested yet about the processes. The things I'm interested in are the signals, because I want to put these signals onto this diagram here so we can see what's happening, right? So to do that, you select all of them, you right click on them, you say add to wave selected signals. And I will try and put that into the chat shortly. Right, and what should happen is that did you try the fix that I said to wave? Right, so
I'm sorry?
no, Yasmin's asking a question in the chat. She said she's still getting the same error that you got, Wei. And I'm just asking whether she selected went right click settings, EDA tool settings, simulation, and select Model Sim Altera. Yeah? Okay. I don't have anything. Let me finish the presentation, and then when we get to the lab section, I'll get you to share your screen so we can try it out, get to the bottom of it. Okay? Okay, so we've got our signals, right? There's our A, B, C, and S. And at the moment, the values of those signals are U. U means undefined. Okay, that's because we haven't run anything yet. We've just started it up, and there's nothing in the memory of the simulation that says what those values are. Maybe I should have set something different in the simulation, in the test bench, but I usually use 100 nanoseconds as the wait time. Unfortunately, ModelSim uses 100 picoseconds as the run length. So I generally have to go in here and change the run length to 100 nanoseconds, right? So I've changed that run length, and then I just hit the button beside it which says run, and it'll run for 100 nanoseconds, right? And you'll notice down here, again, I'll take a screenshot in case it's not clear. In fact, let me put those two screenshots in, right? So there's the one adding signals to the what do they call it? Timing diagram. And then there's the one just now, which is showing the output of the simulation. Right, and remember, it's wrong. I explicitly decided to show an output just by making a wrong output. But what you can see now here, and let me just pull this out as a separate window and make it big, right? What you can see now is now the values of all of my signals are not undefined. If they were still undefined, these lines here, let me see if I can zoom in. It doesn't really do anything, does it? Oh, it's zooming the time value. Yeah. Anyway, what you should be able to see is all of these lines are green, which means they're not undefined. They have a defined value, and that defined value for this particular simulation is 0. Okay, and if we had the full test, and I'm going to do that, and I might take a short break once I do that. Right, I'll go back to my VHT file. What I'm going to do is I'm going to put the right value in. Right, the right printout, and I'm also going to put in a test that carry is 0. Right, so there's a full test just for the case A equals 0, B equals 0, and I'm going to cut and paste those for the 4 other options, right? And I'm going to change that to a 1, and if A is a 1, then the sum should be 1, and if it's not, then that's an error. If B is 1 and A is 0, then the sum should be 1, and if it's not, it's an error. And if A is 1 and b is 1, then the sum should be 0, and now the carry should be 1. Okay, so now I have a comprehensive test for my half adder. Okay, I'm going to have to kick off the compilation again, and it's going to take. In fact, let me do this. Let me try taking a copy of it and see whether it's faster if I don't try and do it over the network. I suspect that's going to be the case, but I haven't actually tried it. Because like I said, it's usually much faster, even on my not very good laptop here beside me. Oh, and I think I'm going to have to kill. I think I'm going to have to kill Quartus to copy it, because it doesn't like being. Maybe? Well. Let's see if it copies. Let me see if I can put it into documents or something. Ooh. Maybe it is copying. Sometimes it gives me an error. Yeah, there we go. Maybe I can do it anyway. Just ignore that particular file. That's a lock file that I think Quartus uses to stop it doing silly things to itself. Yeah, this is probably why the compilation takes too long. I should have thought about that, copied stuff up earlier. Okay, let's wait for that copy to finish, and then I'll kill Quartus and a model sim and restart it up again on that local copy in my documents folder. Okay, so that's done. That should be okay. I should be able to stop my simulation. There we go. Now let's go here to Documents, Lab 3, double click on that one. Let's see if that opens up. Looks like we've got our compilation. So we should be. Oh, we've already. I'm going to have to. Sorry, I shouldn't have started that up yet. I'm going to have to restart the compilation. So what I'd suggest is I'm going to take a 5-minute break again. And I realise it's a little early for a break, but that's okay. I'm going to kick that off and see whether that's going to. It's probably going to be hopefully less than 8 minutes, but we shall see. But let's just take a 5-minute break. Before I do go on a break, does anybody have any questions so far, apart from individual installation questions? Like I said, I'll try and get to individual installation questions shortly when we start the lab section. If not, I'm going to put myself on mute. There's a question. How do you open the VHT file? Oh, okay, that should be... So what you do is you just go open, simulation, model sim, and then you've got to select the right file type, and I can never find it in this list of so many file types. I usually just go to all files and then I find the VHT file. Okay, and that should open my VHT file, which it looks like it has. Does that help? Okay, cool. Okay, so let's do that 5-minute break, and like I said, I'm going to mute Mini-Me on the video, and I'm going to mute me microphone wise, and I'll be back in about 5 minutes. Okay, just about time to start up again. Hopefully our compilation has finished. Oh, look at that, it's finished. And in under 8 minutes. That's good. Okay, so what we did is we rewrote the test bench, and now we need to run the simulation tool. Tools, run simulation tool RTL, and fire that up. I wish I could figure out how to make this bigger, because I'm finding it hard to read from all the way back here. Edit preferences, maybe? By window? Fonts, there we go. So I'm just going to go through and double all of these, see if that helps in terms of point sizes. Ooh, look at that, that's a little easier to read, isn't it? Okay, remember when you start up the simulator, make sure you come here and check that you have two entities in your simulator, the entity under test and the test harness, the test workbench. Right? There's the entity, there's the architecture. If you've got more than one architecture or more than one entity in the file, they'll show up there. I tend to recompile. In this case, it's almost instant, so it's no skin off your nose to do it. And then I hit the simulate. It already started up in simulation mode, but maybe it was probably simulating the half adder rather than the test bench. So got an error that lab3.vhd is not a recognized design file. So let's leave particular questions. What I'm going to do is in probably about 10 minutes, I'll switch over to lab time. And what I suggest is if you have a problem, and a few people do have a problem, you can join the queue now by typing that in your text message, in the discussion window, and that should add you to the queue. And I will talk to people in the order that they joined the queue. So first in, first out. Okay, so we did that. We're okay with that. We recompiled. We started the simulation. So now what we've got to do is we've got to take the objects and add to wave selected signals. Oops. that's there. Let's just kill that. Let's try that again. Simulate. And then maybe I was getting those errors before. Add to wave selected signals, and there we go. Okay, that's alright. Those warnings were happening before. Right, so there are my selected signals, A, B, C and S. And as I said, I'm going to change the time step to 100 nanoseconds from 100 picoseconds. And then we should be able to change things. Right? And if we zoom out a bit, now you can see that we went from A and B being 0 to A being 1 and B being 0, right? There's A, if it'll stay there for me. Right, there's A being 1, then A goes back to 0, and B goes to 1. And then finally we get both of them to 0. Throughout all of that, carry is 0 until we get to A equals 1 and B equals 1. And otherwise, when either A or B, but not both, is 1, then we get a sum output of 1. Okay, so that's the timing diagram. And let's just check the output. There was no error output. That's partly why I actually like putting print statements here, just to convince myself that the tests were actually run. So assert false, report start of test, severity note, and then down here and we'll do end of test, also severity note. Let's just see how long that takes to compile. Hopefully it's a bit faster than before. Looked like it was. Here we go. Somebody's joined the queue. Yeah, that's running much faster than before. Yeah, I shouldn't have tried to run it over the network. That's the problem. There we go, 22 seconds. Much better. So we recompiled that. And I'm just going to kill Model Sim and restart it. Right, so Tools, RTL Simulation. And we should start up Model Sim. We should check that in the Library tab, oops, where have we got to? The Library tab, that we have both of our devices, and the thing we want to simulate is the test bench. So we'll do that. And then we add our signals to the wave. So we've added our signals to the wave, and just so that we can read their names, make that a bit bigger. Change the time step so we don't have to keep hitting 1,000 times. Right, and then Shift F to zoom out to the full length. There's that worked again. Let's go back to the log window. Right, and there's the start of test note, and there's the end of test note. right? And I had to hit run 3 times in order to get from one to the other. That's because, right, my VHT file has 1, 2, maybe I should, well, I hit run 4 times. The first time beforehand, right, I hit run here, and then another 3 times. And that's because I have 1, 2, 3, 4 waits of 100 nanoseconds. So if I'd selected the run length, right, I'm gonna restart it, and if I'd selected a run length here of 500 nanoseconds, I believe I would have seen everything in one hit. Okay, so it depends on how you want to run things. If you want to see it as bits change bit by bit, or if you just want to run the whole test, you can do it that way. Okay. Today's lab is not about the test bench. Next week's lab is about the test bench. Today's lab is about building a full adder and putting that full adder together into a 4-bit adder, or a 4-bit adder and subtractor even. So let me quickly go and talk about that. Does anybody have any questions about what I've been doing with Quartus and Model Sim? I've taken a few screenshots. I will put them up into the lab definition for next week, so that you can make sure you've set up for the test bench, and making sure the test bench compiles, making sure that you can run the simulator, right? Those were the configuration things I had to do online just now. Okay, that's all right. You don't need to know this week, Jordan. Like I said, I'm going to write up the lab in more detail with screenshots, and the lab for the test bench will be doing next week. This week's lab is just another slightly more complicated thing for generating a full adder, and also generating a 4-bit adder using 4 of those 4-bit adders, and maybe some extra bits and pieces. So let's just quickly look at that. So the slides for today have the test bench code, right? And it has the full stuff that I had earlier, right? So that all of those, this is the test bench that was generated using the template writer, and then the pieces that I wrote are between the last begin and the wait statement. So this week's lab, I want you to build a 4-bit adder in Multisim, but to get there we need to build a full adder. The device we made last week was just a half adder. The difference between a full adder and a half adder is the full adder has another input called the carry in. So now we might have to rename the output carry bit to be carry out. And the idea is that if you get 3 1s on the input, so A is 1, B is 1, and carry in is 1, then the sum will be 1, and the carry out will also be 1. Right, so there's the truth table for the full adder. Right, if any individual input is 1, then the sum is 1. Here's one individual input being 1. Here's another individual input. So those 3, the sum output is all 1. And then if you get all 1s on the input, the sum output is also 1. And then the carry is a 1. The carry out is a 1 if any 2 input bits or 3 input bits are 1. And then what we're going to do is we're going to take that as a separate entity, and this, I took this circuit diagram from Geeks for Geeks, and this is not just an adder, this is an adder and a subtractor. Right, so the K input over here determines whether the device does an addition or a subtraction. Right? And the way you tell is because K is coming in here into the first carry input, and it's also on one of the input sides, the B side, determining whether the B input gets complemented or not. Right, so remember our discussion about 2's complement arithmetic? What's happening here is if K is 1, then the B's are inverted. Right, so the B inputs are the output of this exclusive OR gate. If K is 1, then the B's get inverted, but also if K is 1, they have the adder train gets a 1 added to it. Right, so this is performing the 2's complement operation on the B input bits. So what I'd like you to do is to implement, for the lab, is to implement a full adder first in multisim and in Quartus, and then use that full adder that you put in multisim to create a 4-bit adder using this circuit diagram, and then do the same thing again in Quartus. Any questions about that? Okay, if not, what I'll do is I will stop sharing my screen in Discord, and I will start talking to people who have joined the queue. I think we've got 3 people in the queue, and I've forgotten all my... There we go. No, it's not telling me who's here. I'm going to have to check the code. Ah, where's the code? Sorry about this. I've forgotten. This is Professor Broderick's bot. So I've helped him out with it. But right, so yes, you should be able to use static logic vector when we start talking about the 4-bit device, because otherwise you'll have to have A0, A1, A2, A3 and B0, B1, B2, B3 and S0, S1, S2, S3 and C out 1, C out 2, C out 3, C out 0, right? So yes, we do need to use vectors or buses of inputs. Let me, I'll talk about that shortly. Let me just figure out what I'm doing with this bot. Who's next is the command. Join queue worked. I'm wondering why who's here didn't work. Let me just check that the bot is still running. Looks like the bot's still running. That's a little odd. So Tommy, you're first up anyway. It said it allowed you to join. I'm not quite sure why it's decided to go away. So let me stop sharing my screen. And let me watch your stream over here.
Okay, so I don't know where I went wrong really. When I go to run simulation tool, it doesn't give me anything. It says there's an error.
Where does it say the error?
1 sec, I forgot the exact. It says error loading design, pausing macro execution at line 12.
Ooh, that's interesting. So let's can you right click on the project up the top left there and where it says Cyclone IV E
Okay.
and settings. Did it show something? I can only see your...
You can't see it? Oh, sorry.
Yeah, I think you're just sharing the quarters window. You're not sharing your screen.
Yeah, sorry.
There we go. Okay, so simulation, that all looks good. Simulation, Okay. Close that, just hit cancel. Oh, okay, it's okay. Go to Tools and then Options. And then EDA, that looks correct. Okay. Right click on Cyclone file and go to Options, or Settings again rather. Go to, see where it's under General at the top left it says Files, go to Files. Okay.
To add the file here?
Yeah, so browse to the VHT file, it's under Simulation Model Sim, and you'll need to change the file type and get the VHT file, yeah, that one. Hit Apply, okay. Now hit Compile. Just, yeah, just in case it didn't compile. It should have, but the older versions of Quartus were a little flaky. This one seems to be a lot more solid, but I'm a little paranoid about how long things take, so. Okay, so simulation. Oh, ooh. Can you just take a screenshot of that? And actually, maybe I can take a screenshot of that for myself. No, I can't. There we go. Error deleting MSIM transcript, permission denied. I'm wondering whether it needs to be as, yeah, exactly, right. Maybe it needs to be run as...
I'm running as admin, because it wouldn't work last time at all if I didn't run it as admin, so now I just do it every time.
Okay.
I mean, I can restart it if you want.
Yeah, if you wouldn't mind, just to see, we won't have to recompile, just try restarting. I haven't seen that error before. Let me just pull it up. I managed to get a screenshot of it. Let's just pull that there. Error deleting native link. Yeah, see and that report is never quite right. Oh, one thing you can try. See under the project menu. Up in the top, between view and assignments, go clean project, and just yeah, maybe select all revisions, but that just blows everything away, just in case it remembers something incorrectly.
Was that normal?
Yeah, that's okay.
Okay.
And now recompile, because it just blew everything away. And thankfully your compile doesn't take 8 minutes like mine was taking. Okay.
Do I have to open the VHT again, or?
No, just say run simulation tool. There we go. Okay, now let's just check that work. Open up that, click, see the
Sorry.
error reading loading. Yeah, go see up to the top there, click on the plus sign beside work. Right, you've got both of them there. Just select both of those files and then right click and say compile, recompile, and that's okay. And then right click on just the test bench. Yeah, and then say simulate. And that now you should be able to select all of those, all of them.
And you just add,
Yeah.
who's dying?
Here, select all of them, right click, add to wave selected signals, and that should generate the, you can click the little pop out icon in the top right of that wave window to get a separate window, and that should now let you do the simulation. You might want to change the 100 picoseconds to 500 nanoseconds or something. You have to edit it, yeah. Oop, yeah,
And then, how do you like start the simulation?
So just beside the 500 nanoseconds, there's a run button. Other side, yeah, that one. Right, and that should have done something. It looks, and if you hit capital F, that'll show you the whole output. There you go. Okay, so yeah, that looks like it's working correctly. Okay, thank you. And unfortunately, I don't have a way to clear the queue, which is a little annoying. So next on the list was Yasmin. Yasmin, would you mind sharing your screen and getting onto voice, and if possible, and let me know what the problem is. Oh, Javier.
So this
Can't generate. Okay, so go up to the project navigator, right click on Cyclone 4 and goes to settings, and now go down to where it says EDA tool settings simulation, and now you've got to select Model Sim Altera. Yep. And you want to say format for output netlist is VHDL, because yeah, and then you want to down where it says native link settings, select the radio button compile test bench beside where it says compile test bench, the radio button there, click that. Now click test benches, and you may need to add new, so click new, and just give it a name. Maybe it's the half outer test bench or ladder. This will be full adder eventually. I only want you to do the test bench next time. Hold it. You need to, have you created the test bench? Does the VHT file exist?
no.
No. Okay. So what we'll have to go create the VHT file, and we'll have to come back here. So just cancel out of this for now. Yeah, cancel. Hit apply. Right. That's okay. And hit close. Now go to tools and options. Oh, sorry, wrong one. Cancel out of that. Sorry, it's my fault. Go to processing, start. Second from bottom, start test bench template writer. That's doing exactly the same thing. Okay, go back to right click on Cyclone i4 again in the project navigator and go to settings. Oh, it didn't save it. So select Model Sim Altera. Select VHDL in format for output. Hit apply now. And now hit close. Oh, it probably didn't. Yeah, hit close. It's okay. It probably didn't save it because the maybe OK. There we go. Okay, now go to the processing start template test bench writer. There we go. So now you've got lab4.vht in the simulation model sim. Now we have to go back and go back to the settings. So right click on Cyclone 4 settings. Down where select compile test bench radio button and test benches, create the names, create a new one, add a name to it. Lab 4 is probably okay. And then where it says file name about 2/3 of the way down, browse for that VHT file. So see the 3 dots in the square window? Yeah, go into simulation, model sim, and select the VHT file and hit add. Okay, and then say OK, and then say OK, hit apply, and hit OK. Now, if you recompile, that should compile everything, including the VHT file. So hit the blue triangle. Yeah, that one. And what you should see in there, if you should see it compile the VHT file as well as the VHD file. So the Victor Hotel Delta and Victor Hotel Tango files. Yeah, that looks good. So now you should be able to say tools, simulation, start RTL. Yeah, so run simulation tool, and then RTL the top option. Yeah, RTL simulation, and that should start up. Yep, there we go. Now, this will have a test bench, but it'll have a blank test bench. If you go into the library there and see where it says work and click on the plus sign beside work. See the library window just below where you are now, and see where it says under the name column work at the top of the column. Click on the plus sign to open it up. Right, so they're the 2 entities that are in this project. There's the lab 4 entity and the test bench entity. And this should allow. But for this lab, the aim is to just implement first of all the full adder, and then implement the half adder. Sorry, and then implement the 4-bit adder using that full adder.
I have created the full adder right here. Is there a way that I can write out for these for the 4-bit adder, or do I have to write this out 4 times?
Right. No. So that's the next step, which is to create another VHD Victor Hotel. Right. So
within the project, or within the same project, or
in the same project, yes. So new, and you want a VHDL file, yep. And now what you want to do is you probably want to call this one 4-bit adder or something like that. So save the file as 4-bit adder.
It doesn't let me move until I have something in there.
Sorry?
It doesn't allow me to save until I have something in there.
Okay, we'll put, okay, yep. And yeah, just in that directory is fine. So just call it something more meaningful. Like I said, FOURBITADDA. Don't start it with a 4. You need to start it with a letter, which is a bit. That's why I said FOUR. Yep. Okay. So try that, and maybe, yeah, it's okay. That looks good. So now you should be able to do an entity. So Yasmin, I think I've taken you far enough. I got over your problem. Let me go back, because I do need to talk about for the lab. I do need to talk about a couple of other bits. One of the other bits is what was mentioned earlier in the chat, which is the vector version. So we need to maybe use some vectors. And the other one is how do we create an instance. Okay, so I'm going to go back to sharing my screen. I'm going to stop watching yours. Okay, and I'm going to share wherever it got to. My project output, there we go. We'll go live there again. And let me take that off. See, I'm wondering why, and I've been ignoring the chat, so let me just check the chat. Oh, if you're trying to run, you shouldn't have to run as admin on the Citrix server. Abraham, it should be perfectly okay. I haven't ever had to run as admin, and you won't be able to run as admin on the Citrix server. If you're running on your own laptop, then it should be okay. Let me, I'll just get, like I said, there's 2 things I need to talk about to get this lab done. One of them is vectors, and the other one is components. So let me figure out where that is. Okay, so I think we saw in the chat earlier. Let me just pull. Has my Citrix server gone away? Maybe my Citrix server's gone away. Oh, that's not good. Let's do this instead. Okay, VNC viewer. See if that works. Yeah, you should. Like I said, both Abraham and Jacob, you shouldn't have to run as admin on the Citrix server. I've never seen things lock up with the Citrix server. So this is my my local machine, and I'm going to close the project, and I'm going to create a new project with my new project wizard. Alright, and this is lab 4, and the eventual name of this is going to be 4-bit adder. Right, that's where we're trying to get to. Okay, that's odd. I'm wondering whether too many people are trying to run it on the Citrix server. Or the other issue, maybe if you connected up your local drives like I did, maybe it's being a bit slow, and maybe you're better off copying things onto the Citrix machine and running it locally to the Citrix machine. Right, so I'm going to create a project called 4-bit adder, and yes, I want to create it. I'm going to have an empty project. I don't have any files yet, so I can't do anything. I want my Cyclone devices, and I think I want that one there. EP4 CE6 E22 C8. I'm going to select my simulation tool to be Model Sim Altera, and my format to be VHDL already, so hopefully I don't have to keep doing that. Right, and that's what it's going to tell me to do, and I'm going to say finish. Right, so now I've got my my project. I haven't written any VHDL yet, so I've got to do that next. Okay, so now we've got VHDL, so again, file new, and the first thing I need to do is to make a new VHDL file, and let me just check. I'm going to use library IEEE, and I'm going to say use IEEE.stdlogic1164.all. Okay, and then I need an entity, and I have to do a full adder first. So entity full adder is, and then I need to do a port, right? And I need A, B, and C in. And they are inputs of type std.logic, right? And then I'm going to get out S and C out, and I need to put a semicolon, not a comma. S the sum, and C out which are of type output and also logic. And then I have to end full adder, and that should say is, not id. Right, so there's my entity statement for my full adder. Let's just go back to what the full adder looks like. Can I do that? I can. Okay, so here's the full adder somewhere. There's a full adder. Right, so that's the sort of thing I need to do. That's the truth table. I'll let you figure out what the what's happening. Right, and so the next thing we need to do is the architecture. Right, so the architecture is, I usually make it the same name as the entity with just underscore arch at the end. Right, and it's of type full adder, and then is, and then we want to do an end, and I think it's end architecture. Let's just end the name of the architecture, end full adder arch. And let's just see if that compiles. Actually, let's save it first. And let's call it, this is not the top level entity, let's call it, this is full adder. And this is probably going to give me an error because we don't have a top level entity called 4-bit error, 4-bit adder. But I'm hoping it's not going to give me any errors as far as the full adder pieces are concerned. Just thinking about it. Oh well, there was an error. Let's just have a look at the lab 3 one. Oh, I left out the architecture keyword. That's probably part of it. Right? But it also should have told me that it couldn't find the top level entity that I told it was 4-bit adder. It may also be giving me an error because I actually haven't done anything in the architecture. Yeah, so let's just see if we can do something in the architecture. So let's have a look at what the sum output should be. And the sum output should be basically something like A exclusive or B exclusive or C in. And the C out output should be something like, now this one's a bit trickier, it's going to be A exclusive or B and, let's just make it lowercase, and C in, That's one side of the OR. And then the other side of the OR is just A and B. And I think that should implement a full adder, but I haven't checked it. Let's see what that gives me. So nothing I've done so far should be particularly new to you, right? We did all of this last week for the half adder. What I need to do next is I need to start defining the full adder. Near text S semicolon. That's... Oh, I forgot the begin statement. Doh! That's the problem. There we go. What I need to do next is I need to define the 4-bit adder entity, and there's two things that we haven't done yet that we need to do. One of them is to use buses or vectors of bits, and the other one is to use so now my VHDL is okay, except that now I don't have a 4-bit adder top level entity. So let's now do another file and another VHDL file, and let's just steal that. In fact, let's steal this, and let's call this 4-bit adder. And call that 4-bit adder. Now, one way I could do it is just being silly, right? I could do that, and then on the output I could do that, and that gives me 4 bits in. Let's just go back to the circuit diagram. Oops, got to swipe that away and bring that over. That will let me take 4 bits in and 4 bits out, or 5 bits out, carry out. Well, a total of 8 bits in, 9 if you include the K option. Right, remember what K is doing is it's allowing us to swap between addition and subtraction, which is for a 1 extra input and 4 extra gates is pretty nice. Right, so there's our entity for the 4-bit adder. Let's just save that. Right, and now we need to put together the architecture for the 4-bit adder, and remember to have the begin statement. Now this lab, you are probably not going to be able to submit by the end of the class. I apologize for that, but the reason I forgot to add. The reason is because from lab 4 onwards, I want you to write things up in a bit more of a professional way. And that's why I've included these notes. Let's see if I can... Right, these are some notes I wrote quite a while ago. I think I updated them this time last year. And what do I look for in a report? Right? There should be an introduction, a problem statement, a laying out of the experiment so that somebody can reproduce it if they want to, a presentation of the results, maybe a discussion, maybe a conclusion. I don't tend to get too hung up on spelling or grammar or formatting, except, as it says in italics here, if it stops you communicating clearly. If it stops you communicating clearly, then I need to comment on that, and it will probably reduce your grade anyway. For this class, you probably don't need to reference anything, but if you do, please use a known citation style. I recommend the IEEE style. There are others, but the IEEE style is the one that people in our profession tend to use. So this lab, if I can go to the labs page, maybe. Right, this lab, which is down there somewhere. This lab, I want you to submit a report based on those notes. The notes that I just went through are also attached to Lab 4, so have a read through that. And the aim of the lab is to implement the full adder in multisim, the 4-bit adder subtractor in multisim, and then do the same thing in quarters. This is going to take a little bit more time than we have during the session. That's why I'm going to do the same lab next week, except I'm going to add on what we just did in the class today about the test bench, right? So you're going to have time again next week to get it right, get this part of it right, because we're reprising it next week, but we're trying to add in a test that tests the 4-bit adder. Hopefully we add a test that tests the full adder as well. Okay, so my 4-bit adder compiled, but I don't like the fact that we've got these silly variable names, right? So what I'm going to do is I'm going to redo it using vector notation. The carry in and the carry out are both okay as bits. And I have forgotten, it's probably in the chat there somewhere, what the name of somebody posted it earlier. There it is. Student logic vector, I think it is. Yeah, there we go. Right, so what we need now, instead of student logic, is student logic vector, and then we need to give it the size, and it's a 4-bit input, so it's 3 down to 0. and I need to put a semicolon there. I need to put a semicolon there, and then my sum, let's just make all those full colons line up. Now let's just see that I've got the syntax right. I think that's right. Okay, so now what we've done is we've said we've got a vector of std logic elements, and that those std logic elements are numbered. Okay, there were some warnings there, but it's looking all green other than those warnings. There's no syntax errors, which I was afraid of. Okay, so that was the first new thing, how to deal with buses or vectors of bits. So the next thing is how to get instances, and I'm going to have to cheat. Right, so now what we've got to do is we've got to make instances. We've got to make, let's just go back to our circuit diagram. Right, we've got to make, we've made the full adder in our project, and now we have to make 4 instances of that full adder in our 4-bit adder subtractor in order to get it right. Subtractor, I forgot to add the K in, right? So rather than have a carry in, I'm going to have a I'm going to call it subtract, right? Because if K is 1, then that forces the B input. If K is 1, that forces the B input to be 2's complemented. And then we're adding the 2's complement. Okay, in order to get an instance of an object, what we've got to do is we've got to create it. And the way we create it is by saying something like adder 0, that's the name that we choose, and it's of type full adder, that's the name on the VHD file. And then, like we did in the test bench, we need to use that port map idea, right? Yeah, port map, and then we need to map our A and B individual bits to the inputs on one full adder, right? So let's do this one first, A0 and B0 and K. So I'm just going to ignore K for now, and I'm just going to connect B0 and A0 and A1 and B1 directly in the port map. what I'll have to do is maybe I'll have to take that out, because that's going to be a bit more complicated than I expected. Anyway, what we can do is map the, where's it gone? Map the these to these, right? So let's do that. The map I have so far is I want to map the A on adder naught to A naught. I want to add B on adder naught to B naught. And maybe what I should do to make the distinction between the two is to rename them, right? That might make things a little bit clearer rather than confusing A's, B's and C's, right? So I think I'm getting that the right way around. I may have it the wrong way around. Let's just try it. Right, so the full adder, let's just go back and have a look, has A, B and C input and S and C output. So A, B and C input, and we wanted our C to come from, I'm thinking that's the wrong way around, but I could be wrong. Come from like that. And then let's go back to our circuit diagram, right? We want the carry output of this full adder to go to the next full adder, right? And we want the sum output of the first adder to go straight to the output. So the S goes to S out 0, and then the carry out from this device, and I may have to do something tricky, so let me just, the carry out from adder naught goes to I think it's going to be the carry in on adder 1, and I've forgotten the syntax. So adder 1, C in. Let's just write it like that for now. And I'll go back and check that I have the right syntax. Okay, so there's a first instance. I need 4 more of them. Right? I need 4 full adders to make a 4-bit adder. And now I need to connect up these. And I need to connect those, and then the final carry out of adder 3 goes to carry out on this entity. Now I suspect that's not going to compile, but let's try it anyway. So they're the two things, and like I said, I think there may be a third thing that I don't want to go into today. What I might do is I might roll up is used but not declared. I need to add a component statement. Sorry, I should have done that. Yeah, so I need in here, I need a full adder component statement, and that should get rid of at least one of the errors. Oh, sorry, still. I need to end component as well. Yes, that's right, Kyle. There's going to be 4 object. Oh, okay. So unfortunately, I need to declare things I use. So I suspect, rather than doing it in that order, I need to do it in that order. Right, let's just see if that works. So let me do this. This is maybe a little bigger than I thought it might be. So what I'll do is I'll move out the due date for lab 4 until 2 weeks time, and but I'll get you to also do the test bench within lab 4. So we'll spend some time next week during class going through it, and I'll try and figure out why I can't prefix. Okay, so does not declare an object to denote an object that declares a named scope. Yeah, I'm probably not referring to the inputs or the connections in the other device correctly. Let me quickly see if I can figure that out.
Did you mean to put SL4 or was it supposed to be SL3?
Oh, you're right. That's Sorry, I just dropped my mic. Yes, you're right. There's going to be no.
It's never declared a 4.
Yeah, there's no 4 declared, so that's going to have to be a 3. But I don't think that was the error it was generating. Maybe it was. Let's try it again. Yeah, so that's prefix does not, and it's about, does not denote an object in the declared scope. I think it's complaining about this adder 3.cin. Yes, I was afraid of that. Okay, so what we've got to do is, I can't just connect up, let me just make it a bit bigger so we can see it. I can't just connect things up like that. What I have to do is I have to create some temporary signals or temporary variables in order to do that. So let me do that. So what I'm going to do is I need several temporary carry bits, right? And to do that, I do it before the begin of the architecture, and I prefix it with signal. And then I'm just going to go C1, C2, C3, maybe C4. I don't know whether I need C4. And they're going to be of type std logic, which I could type. And then the carry out now, actually I think I should start with C0. That's the carry out for C0, right? And then I should put the C out of here. And the thing I didn't do correctly is I need to put the carry out of the 0th adder into the carry in of the next adder, right? That's what's happening here. Here's the carry out of the first adder. Here's the carry in of the second adder. And the only way I can do that is by declaring these temporary variables. That should be C2. I don't think I need C3. Let's see what that does. That might improve things a little bit. Okay, so all I did then is I just connected up this line, and these here are going into temporary variables in between times. Yeah, that's looking better. Okay. that's all you have to do for Lab 4, but like I said, I'm going to update it. I'm going to push out the due date, and I'm going to add the requirement that you write a test bench for the full adder as well. That's a little longer than I normally run. I hope it was worthwhile. I hope it wasn't too tedious. Let's leave it there for today. Before I sign off, does anybody have any questions about where we are so far?
I have a quick question about the full adder sum of product.
Mm-hmm.
You have the S outfit to be exclusive OR of A, B, and Cn. I was just wondering what you do with the condition of all of them being true, so A, B, and Cn being true.
Okay, well let's see what that does, right? A, B, and C in true. Then we get A, 1 exclusive OR 1 is 0. And we get 0 exclusive OR 1 is a 1.
Okay, thank you.
Okay, I think that's doing the right thing, because if all three inputs on the full adder are 1, then we want both the sum and the carry out to be 1. Okay?
Realize the order of operation.
It doesn't really matter, but if you really wanted to make sure you understood it, you could put in some orders of operation like that. Or I've forgotten, let me go back to the actual slide. Right, I think I did A, B first, A exclusive or B first. So if you really wanted to make sure you implemented it the way the circuit diagram shows, then you would put the parentheses around A exclusive or B, and that way that'd get done first, just like it is in the circuit diagram. Okay? You're welcome. It shouldn't matter for this particular example, but yeah, you're better off doing it a bit more correctly. Okay, thank you very much, everyone. Any other questions? Post a screenshot of the 4-bit? No, that'd be cheating. Of course I can. Let me copy that, and I'll paste that into the probably the materials. Okay, it's a bit hard to see, but because it looks like the background is transparent, but that's available now in the materials chat. Okay, let's leave it there then. Thank you very much for your attention.